Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapiens Education. For more details, you can visit our website www.sapienseducation.com. So today I am going to cover part 3 of the video. Already I have taught two parts of the rotational motion and its system of particles. Now, in context with the rotational motion, I want to teach you about the angular velocity and its relation with the linear velocity of the system of particle. Okay, so what actually angular velocity is? So see here, you have already read about the velocity, linear velocity, but in angular velocity what happens? See here, for example, this is a lump of a body. Okay, lump of a body or stone like body you can think, and about this point, about this axis, it is being rotated. As it is being rotated, so every particle will be make a circular motion. Every particle of this body will make a circular motion, right? So as it makes a circular motion, and when this particle has a position p, and after some certain period of a time its position become p dash, and at that instant its angular displacement, that is delta theta, is your angular displacement, right? And r is the radius, and for a time t, delta theta is the angular displacement. So can we write here that angular velocity is what? Angular velocity can be written as omega, can be written as delta theta, that is angular displacement by angular time period delta t. So if delta t tends to 0, very small, if I will talk about very small time interval, then we can write here this equation as omega is equal to d theta by dt. So this is all about the particle's angular velocity. So every particle in the rotational mechanics, every particle of the system will rotate with the angular velocity omega, and every particles have same angular velocity. Every particle have a same angular velocity omega, right? So any particle will try to form a circle when it rotates. So this is all about angular velocity. Now its relation with the linear velocity. So linear velocity, for that instant, v is your linear velocity. When a particle is at a point p, so for that instant v is your linear velocity. Okay, and omega is the angular velocity. Now how to find a relation between these two? See, as we have seen that in a circular motion there is a instant velocity v, and omega is your angular velocity, and r is the radius. So we can write v is equal to r omega. V is equal to r omega. If we talk about the cross product or vector form, we can write here vector form as v is equal to r cross omega. As we have seen that r cross omega, if you will do r cross omega, so see here, if I will do r cross omega, this is your r and this is your omega. Omega is in upward direction. So when you do cross product, so you will get a velocity in this direction. So in the vector form we can write v is equal to r omega. Okay, or we can write omega. So if we want, see if we want instant velocity for a particular particles, for every particle, if I will if I want linear velocity, so we can write vi is equal to omega I into ri. We can write in the vector form, we can write here omega cross r. Now let the angular acceleration will be denoted by alpha. Alpha is your angular acceleration. So how you will find a relation of linear acceleration with the angular acceleration? So as we know that linear acceleration is the rate of change of velocity with respect to time t, and it is a linear. Now we have already derived v is equal to omega cross r. So can we write here in place of v, we can write v is equal to omega cross r. Since for any particular particle, radius will be constant, so can we make it out radius as a constant, so we will get dw by dt. So what is the rate of change of angular velocity? So since here we have seen that rate of change of displacement is your rate of change of dx by dt. Dx by dt is your velocity, linear velocity. D theta by dt is your angular velocity. Velocity, rate of change of velocity is known as a linear acceleration. So similarly, rate of change of angular velocity with respect to time can be written as alpha, that is angular acceleration. So we have got alpha is equal to a is equal to alpha cross r. A is equal to alpha cross r. So this is the confined relation. Okay. So you should memorize this relation. I hope you all have understood these three important relation. That is, one important relation is your d is equal to omega cross r. Acceleration is equal to alpha cross r. So this is the very important relation. So you should memorize this. Okay. Now I am talking about torque. What is torque? So have you heard about torque? The tendency of a force to rotate the body to which it is applied is called torque. Torque basically means what? In linear, for example, there is a linear velocity or linear displacement of a body happens. So we need a force. But when we talk about the when we talk about the angular movement, angular displacement or angular velocity or rotational, we can directly tell that if there is any rotation, so it does not require only force, it requires a torque. So rotation happens due to combined effect of rotation happens due to combined effect of force and distance, and this combined effect is called torque, and due to torque only we able to rotate any body. So mathematically torque can be written as the product of force applied and the perpendicular distance between the point about which the object is being rotated and the line of action of force. So let us consider this. See here, if I am considering this is as a body, this is as a body, and this body is being rotated about a point O. This body is being rotated about a point O, and for rotating I am applying a force of F at this point, and the distance between this object and the force is R. Now torque can be written as force into perpendicular distance. Force into perpendicular distance. See, try to understand here. Here perpendicular distance between which? Between the line of action of force. So let us consider this is a line of action of force, and this is your perpendicular distance. So this distance I am talking about. So by using Pythagoras theorem, can we write suppose this is your angle theta, so can we write here r sin theta because it is your r. So torque is your what? F into r sin theta, and that is torque is equal to F cross r. Understood? See here, we cannot write directly this point as r, just multiply it r by r. For example, if you will multiply it by r, so it is a longer distance. But torque only tells you about that it is the product of a force and the perpendicular distance between the point about which the object is being rotated and the line of action of force. Suppose a force is acting, so draw a line of action of force, a line along the force direction, and the line which is perpendicular to this is known as r into sine theta. So you will get the torque. Now see the diagram. Due to torque, this rotation is happening. Okay, this rotation is happening due to torque only. Now I will tell you that torque is force into distance. Now if for example this body required 100 Newton meter of torque, how much Newton of a torque? 100 Newton meter of a torque. So I am applying a force of 50 Newton, and the distance between this line of action of the distance between this line of action of force and the point about which it is being rotated is your 2 meter, is your 2 meter. So finally combinedly we are getting 100 Newton torque. So whatever method you will use, you need to apply, always you have to apply a 100 Newton meter torque. Now if I will increase this length to 4 times, so see here 25 into 4, so only 25 Newton of force is required. So if we want to decrease the force, suppose I have a limited amount of force. So if I want to decrease the force, but I have to rotate this object, so we have to increase the length. And if have a sufficient amount of force, so if I will increase the force, so definitely from less distance you can able to open this nut or nut, right? So this is what about the torque is. I hope you all have understood now. Torque has unit of Newton meter, because force is in a Newton and displacement is in your meter. Now I will discuss about couple. What is couple? A couple means what? When two equal and opposite force are acting. See here, when two equal and opposite force are acting. It is defined as the combination of two equal force but acting in opposite direction and not acting along the same line. Not acting along same line. Suppose there is force is acting downward, so it can't act here force. If it will act, so no couple will be formed. So for couple, it is always necessary that you require at least some distance. 12 maybe 0.01 meter also, or 100 meter also. But we always require a distance. Whenever we require distance, then only we will get couple. So total force should be 0, because suppose equal and opposite, we are talking about equal and opposite force. Suppose this force is 10 Newton and this force is 10 Newton, so both are equal and opposite. So this 10 minus 10, so this will be 0. And the distance between these two force has been applied should be at least some non-zero distance. Then only couple is formed. But in torque, you have applied only one side force. But in torque you have applied only one side force, but in couple you have to apply two side. For example, you can see the diagram. In diagram, we are applying a force from two sides. Both are in opposite direction. Due to this, rotation is being there, and this is called couple. But as we talk about torque, so we have to apply a single force. So this is very important. We have to apply a single force. Now basically difference of the couple and torque is that in couple both the force are externally applied. See, in couple we are applying force externally. But when we talk about a torque, see here, externally only single force is being applied. But you know that if you are applying a force externally in this direction F, so there is also a reactionary force which is equal and opposite, which will act automatically by the object. But the same thing, see here, both are equal and opposite force are being applied. But here we are applying only from external source. We are not applying both the forces externally. One is a reactionary force. Automatically it will come to play when you apply a single force. A reaction force will be there. So basically there is no difference, but only the difference is that in couple we have to apply both the force from externally, but in torque we have to apply only one side, one force, and the other force will automatically will generated by the reaction force, and this is called reactionary force. I hope you have understood. There is no difference, more difference between couple and torque, and it has a unit of Newton. It has a unit of Newton. Okay. I hope you all have understood this topic. And for today, it's over. Thank you, everyone. Thank you.